Hi, we are starting with acids, bases, and salts. So, what is an acid? So, acids, if we talk about the characteristics, we already know that acids are sour in nature, right? But we cannot taste each and every acid to detect whether it is sour or not. Yes, because some of the strong acids are there, like hydrochloric acid or sulfuric acid, that can burn our tongue. So, how to check that the solution is acidic or basic? To check that, we have several indicators. Now, what are indicators? Indicators help us to identify that the substance is acidic or basic. So, one such indicator we have is the litmus paper. So, you can see here the litmus paper, when we are dipping it into the solution which is acidic in nature, so you can see that the litmus paper is turned into red color. So we can conclude that it turned the litmus paper from blue to red. So one characteristic, what we said, that they are sour in nature. The second one, we said that it converts the litmus paper from blue to red. And the third characteristic is that acids are corrosive in nature. It means that when it reacts with the solid substance, it has the ability to corrode it. Yes? Now, if we talk about the examples for acids like HCl, hydrochloric acid, or HNO3, or H2SO4, that is sulfuric acid, always you will see that the hydrogen ions will be present here. Yes, so we can say that an acid is a hydrogen containing substance that has hydrogen. Now, when we put the acid in the water, it donates hydrogen, right? So we can write the definition as that they are the hydrogen containing substance that is capable of donating hydrogen ions or the protons, we can say, right, or the positively charged ions to the another substance, right? What I said, that they are the hydrogen containing substance that are capable of donating that protons to another substance, right? Now let's discuss about the bases. What are bases? Bases, we already know that they are bitter in taste. Yes, again we cannot taste each and every acid. And we know another quality, that they are soapy to touch as well. Now if we talk about how to check that, again we have several indicators. Indicators, I already told you that they help us to detect whether it is acidic or basic. Now what if we put the litmus paper into a base? Now it turns the litmus paper into blue. What I said, that in the previous case when we were discussing about the acid, it was turning the litmus paper into red. Now base turns the litmus paper into blue. Now what if the litmus paper is already blue? It won't change its color again. So when I say that it is blue already, and when we are putting it into the base, so it won't change its color, it will remain as blue only. And what happens if we dissolve it in water? In the previous case, for acids, we said that when we are dissolving it in water, so it was donating the hydrogen atoms. Here, when we dissolve it in water, it produces hydroxide ions in solution. Clear? So for base, they are producing hydroxide ions. For acids, they are producing or donating the hydrogen atoms, right? Hydrogen ions, sorry. Now, what are alkalis? The bases that are soluble in water. It's very simple. Bases we have already studied about. Now the bases that are soluble in water, they are called alkalis, right? For example, the sodium hydroxide or potassium hydroxide or calcium hydroxide. So they all are alkalis or the bases that are dissolved in water. Now salts, they are produced as the reaction between the acids and the base, right? We already read about acid and base reaction. When acids reacts with base, we already know it is a kind of neutralization reaction in which salt and water is formed, right? One such example for the salt is the table salt that we have in our house as well, right? Next, let's discuss about the reactions. Now, what if the acid react with a base? What if the acid react with metal? Then acids react with metal oxide and metal carbonate and bicarbonate. So, when acids react with a base, it is a kind of neutralization reaction that we have already studied earlier. So, for example, let's take one acid, for example, HCl. When it is combining with a base, for example, sodium hydroxide. When the two are combining, what we will get as a product? We will get salt and water. So, salt, that will be NaCl, and water will be there, right? So that will be the equation for the neutralization one. So this is the example for the first one. Now what if the acid is, if we put it into the metal? Now if the acid we put it into the metal, we will get the metal salt and we will get the hydrogen gas is evolved, right? In the third case, we will see the examples for all of them in the next slides, but here we are just discussing about what will be the products here, right? So what if the metal oxides react with acids? Now here if we talk about metal oxide, so we all know that metal oxides, they are basic in nature, and if the acid react with base, so it is a kind of neutralization reaction that we have already studied here. So salt and water will be produced as a result. Now for the last part, if we have acids when it is reacting with metal carbonate and bicarbonate. So we will get three products, that will be a salt plus water plus carbon dioxide. Now let's see the reactions of acids with metals and reactions of bases with metals. So now we have seen that acids when it reacts with metal, so a salt and hydrogen gas is produced. In the same case when bases reacts with metals, so a salt and the hydrogen gas is produced, right? Now let's take the examples for any acid and when it is combining with a metal. So any acid, let it be hydrochloric acid, that will be HCl. When it combines with a metal, let's say zinc, so it will produce a salt and the hydrogen gas. So a salt will be produced, that will be zinc chloride, and hydrogen gas will be evolved. Similar to that, if a base instead of acid react with a metal, so what will be formed? Salt and hydrogen gas will be formed in the same case as well. Now, any base we are taking, let it be sodium hydroxide. When it is reacting with a metal, again we are taking it as zinc. So what will be produced as a product? So a salt will be produced, that will be sodium zincate, and hydrogen gases evolved, right? Now we have one experiment based on the previous equation. So now here we have the zinc granules when it is reacting with dilute sulfuric acid. Now zinc granules when it is reacting with the sulfuric acid. So zinc is a metal. Again, when the metal reacts with the acid, so the salt and the hydrogen gas is produced. Now here are the zinc granules that we have that are there in the sulfuric acid. So the gas that will be produced and passed from the delivery tube will be the hydrogen gas for sure. Why? Because when metals react with acid, so the hydrogen gas is produced. So here the bubbles will come out of it, and when we bring a candle near to the bubble, so we will able to hear the pop-up sound because of the burning of hydrogen gas, right? Now next we have the reaction of metal carbonate and metal hydrogen carbonate with acid. So one metal carbonate, let it be sodium carbonate, and metal hydrogen carbonate, let it be sodium hydrogen carbonate. Now in both the cases, when it reacts with the acid, let it be HCl, in both of them, we will get the same product, that will be the salt, water and carbon dioxide. So salt that will be produced will be sodium chloride, and water and carbon dioxide will be produced. In the second case as well, sodium chloride will be the salt that will be formed, and apart from that, water and carbon dioxide will be produced. Now, next we have the reaction of the non-metallic oxides with bases. So, for the metal oxides, when we said, so metal oxides are basic in nature. Metal oxides, they are basic in nature. Metal oxides are basic in nature. Most of the metal oxides. I'm not saying all of them. Then if we are talking about non-metallic oxide, so non-metallic oxides are acidic in nature. So non-metallic oxides are the acid content. When it is reacting with the base, so it is making it neutral. It means when the acids reacts with the base, so it will give salt and water that we have already read in the first experiment, right? So non-metallic oxides, they are acidic in nature, and when it react with the base, it will turn it into the neutralize, and the salt and the water will be produced as a result, right? Now, what does acids and bases have the things in common? Now, if we talk about acids and bases, the common thing that both acids and bases are electrolytes. What do you mean by electrolytes? Like we have already learned about electrolysis, right? So both of them are electrolytes. It means that both of them are good conductor. They can conduct the electricity process. Yes. So it means that they are the good conductor of electricity and can conduct electricity in the process of electrolysis. So the both have common in acids and base. The quality that is common is that both are electrolytes, right? So acids, when they are dissolved in water, so what they release? They release hydrogen ions, right? And bases release the hydroxide ions. The process of mixing acid and bases in water is an exothermic process. Now, what does it mean? That when we are mixing acid into water, so it is making the acid diluted. Apart from that, it is a kind of exothermic reaction. What is exothermic? in which the heat is evolved, right? The heat will come out of that. Yes, it means the heat is involved in the process. It is not involved, the heat is evolved in the process, right? The heat will come out of that. Now, what happens to the acid or base in a water solution? We have already read that acids in water solution, it dissociates H plus ions, and bases, when it will dissolve in water, it produces the OH, that is hydroxide negative ions. So now if we are asked with the definition of strong acids or weak acids, so how we can define it? As we know that acid contains the hydrogen ions, so more the number of hydrogen ions it is having, so we will consider it as a strong acid. And the lesser the number of hydrogen ions, the weak the acid would be. Similar to that, for bases as well, if we talk about base, so it donates or produces the hydroxide ions, right? So the more the number of hydroxide ions are produced when it is dissolved, so I can say it is the strong base. Than the lesser the number of hydroxide ions it is producing, so it will be considered as weak base. Now we have the universal indicator, that is the pH scale. Now pH scale helps us to identify how much acidic or how much basic the object is. Now here this number 7, which is there in the middle, it is representing neutral, right? If we are moving from 7 to towards upper numbers like 8, 9, 10, 11, 12, 13, 14, so it is representing the basic content. As we are moving on to the lower numbers, so it is representing the acidic contents. As we are moving from lower numbers to lower numbers, so here the acidic content is increasing. For example, if I ask you the acidic content of this 6 or number 4, which has greater acidic content according to the pH levels, so the number 4 will have more acidic content, it shows. Similar to that, as the number increasing, it shows more basic content in that manner. Now we have some other indicators. Now litmus paper we have already discussed. That litmus paper, if you put it in the acidic one, so it turns the litmus paper into red, right? And for base it turns it into blue. For turmeric, it does not change on acid, but on base it changes the color to red. Then for phenolphthalein, it changes to the colorless for acid, and it changes into pink color if we put it into the base. For checking the methyl orange with acids, so it turns it into red, and for base it turns it into yellow, right? Now what are olfactory indicators? Olfactory indicators means the substance whose odor changes if we put some acidic or basic content in it, right? So for example, vanilla and onion. So the vanilla and onion smell diminishes when we put it into the base, and it will remain same when we put it into the acid, right?